Okay, so further the discussion on shadowing glitches. So we'll proceed on desktop. So this is Linux Mint. Okay, so we'll see the concept of the shadowing in the OpenGL, and we'll see the problem, and then we'll see the scenario, texture object and what is texture unit and why it's happening, and then later we'll see the resolution. Okay, so how problem kind of it is arising, so that situation we'll talk. So we have talked in a detail that what is the shadowing idea behind the scene. So if there is a kind of object, so there are models, and if we need to draw these models from the camera perspective, then I can draw it the way it is, but if I want to draw the shadow also, then from the light perspective also I have to see these models, and then we can draw the shadow. So this has already been kind of explicitly in detail it is covered. So if I consider light as a camera, okay, then light I can bring to origin through some transformation and rotation, and then if light comes to origin, then from light source it would see the models like this, okay, that we can kind of estimate from here only. So if I consider light and the direction in which it is seeing the model, so if I am concentrating on this model, then this is minus z-axis. If this is minus z-axis, then if I transform the light to the origin, then it would see in similar fashion. So if that is the scenario, then I can capture this. Okay, so whatever I see in x and y direction or s and t direction, so that will become a left, right and top bottom, and what we see in the z axis, that would become a depth value. So this is what we are seeing. Okay, so this is the photograph that is taken from the light, and that photograph white means there is nothing behind the scene, so this is the maximum distance, and then gray color is the surface, what we see as kind of orange surface, and then what we see as a blue, a sphere, so that is even near. So this is the scenario that we are saying. Okay, so now from the camera perspective, so if I want to draw it, then for each pixel, so if I take a pixel anywhere here, then for this pixel we'll again calculate the z-axis distance from the light source, and for this pixel that z-axis distance will be compared against the z-axis distance at the same x and y location in the image, and that will have less value because bigger sphere is coming into the picture which has less depth. So in that sense, this pixel would be candidate for the shadow. So this is the analogy that we have seen. So this is become a candidate for the shadow. So we can see the shadow. Okay, what would come as a texture map? So texture map is nothing but it's a raster image which has width and height, and its value is as the depth value. What we see the depth in the z-axis minus z-axis, those values we see. So if it is 1, then there is nothing behind the scene. So this is the GLU perspective frustum. 0.7 means there is some surface, and 0.4 there is something more near to it. That is the sphere, blue sphere that we are seeing. Okay, so same thing we can see. So if I kind of draw a frustum, a GLU perspective frustum from the light, then frustum is like this. Okay, so if I take in the beginning pass in the texture making pass. So if I consider this frustum, okay, then in this frustum we see the sphere and we see the plane. Okay, now in the final pass again we draw the frustum. So in the beginning pass, when we draw the image, then whatever is near the light source, that will come into the image, and far would not come in the image. Like we see the image, what we can see. So all the points that is behind the sphere would not come into the picture. Okay, so that is the shadowing pass. Okay, so while in the final pass, for again we'll calculate the depth value from the light source, and we'll compare the depth value what we see against the whatever the depth value in the texture. And if depth value is more, then it is candidate for the shadow, that shadow we are seeing from the camera perspective. So this is what we are already been seeing. Okay, so what is the problem? So problem is like, if I have a light source and we have a frustum. So this frustum, like if it is a GLU perspective frustum, then frustum has a kind of distance from the light source, and frustum has angle. So if the frustum is exactly same for the camera and the light, still we will see the image differently, and that is differently what we are talking about. That depends upon the what is the Z value. So if from the light source, okay, so from light source, if these models are near, then these models are from the camera. Okay, so then we will probably get different kind of images, like what we are seeing now. Okay, so this light source is near to these models, and so these models are coming inside the frustum of the light source. But if I see this as a cone, if I make this as a cone, the lower part of the cone is not coming in the frustum. But whereas since they are distant from the camera, so everything is coming into the picture, even though there is one more sphere that is also coming into the picture. So the picture that is taken from the camera, it is broad, and the picture that is taken from the light, since frustum distance angle is same but distance is less, so less things are coming into the picture. Okay, so it is like what I am talking is okay, so this angle is same. This is what I am talking. This angle is here and here. This angle is same. So frustum is exactly same. Okay. And but the distance. Okay, so the distance from the light source to these models. Okay, so this distance is different. To make it more clear, I can bring the light source even near. Okay, now distance is certainly different. So I can say it like this distance is D1. Then this distance is kind of D2. So both are different. Okay, so how it makes difference? If depth value is different, then how things changes? Okay, now if I take the photograph, then this yellow color sphere would not come in the light photograph, and then the cone bottom part is also not coming. So in the photograph only this much will come. Okay, so information is missing. Those information are available from the camera perspective. but those information are not available from the light perspective. Okay, so we'll see kind of how actually OpenGL works. So if I have a kind of model, we consider model is always placed at the center. So if model is placed at the center, that means origin of the model is placed at the center. Now at the surface of the model there is any kind of point, physical point, that is x, y, z. Now if I do the transformation of the model, then model reaches somewhere in the space and same pixel is x1, y1, z1. Now after that we apply projection matrix on top of it, and this x, y, z become x2, y2, z2, x1, y1, z1. It is something like, if x1, y1, x, y, z is the point when model is placed at the origin, if I multiply with the transformation, then it becomes x, y, x1, y1, z1. Similar as I multiply this with model view matrix x, y, z, then it becomes x1, y1, z1. Again, whatever x1, y1, z1 I receive from here to here, again it is multiplied matrix with projection matrix. It gives us x2, y2, z2. That is different in both scenario. Okay, so projection matrix is same in both scenario, but transformation is different. If transformation is different because the minus z value, the depth value, because light source may be near to the model than the camera. If that is the scenario, then camera is able to capture other models also, where light model is not able to capture other model. Only it is restricted to some part of the model scenario. So the image, like in the real scenario, I have taken the image. See, we can see image, even cone is coming only little bit, I believe not 100%. And so this is the actual scenario. Like if I seeing from the z-axis, then there is a ball, sphere at the center, and there is another wired sphere, a wired cone at some location, and there is a light source. Okay, now from the light source is seeing this wired sphere, and image is coming, wired cone, image is coming here. Since this red ball is not coming in the frustum of this light source is very near to this, so this red spot is not coming in the frustum. If that is the case, then in the real photograph, what we are capturing, the red ball is not coming. It is a black and white image. Only cone is coming. We can consider red ball as this ball, yellow ball. It is not in the frustum of light. If it is not in the frustum of light and it is in frustum of camera, then it is coming from the both view. Now this is the original view. Okay, first it is taken as what we see the object texture object, we will talk later. So texture object and its attribute. So in that scenario, this is GL repeat. If GL repeat is happening, then this image is getting repeated. If it is a clamp, then it will get clamped. What it is happening? So if the frustum from the light source, these models are near, the image that is getting generated is small. If this image is small, image has to be laid out on the big photograph, then either it would be get repeated, so shadow is getting repeated, or if I set it at GL clampage, it would clamp. This is completely unwanted. We have already removed the shadow acne. Okay, now that is because of the texel density and pixel depth density are different. So in that way, shadow acne we get. But we are getting another unwanted thing, that is because of the frustum, the texture what we are taking, the texture is small and texture is forced to repeat in the shadow, or it is getting clamped. So this is another view taken from the x-axis and one view taken from the z-axis. So looking in the minus z direction. Okay, so certainly we can see the red spot is at center, and there are two planes, yellow plane and there is one kind of gray plane. So they are kept like this, one gray plane and then yellow plane, and then light source is seeing the cone and clamp edge and GL repeat. So this is completely undesirable. Means I cannot have a model which have these many shadows. So shadow can only be one. Okay, since the light source is only one. Okay, so this is a big concept of research, and how we can bring the images that is coming from the camera and the image that is coming from the light source, so they should have equal depth. Now again we'll go with some biasing, and then we'll try to bring it in the same depth. So that is not required. Means we'll see what can be the solution. So this is the actual image from the that we have, that we'll see. So actual image doesn't have even full cone. So red spot is anyway, it is going out of the model. So if we can see this white sphere, it is seeing at the cone here, then it is coming out of the projection. So one way is we have to set the angle of the projection is big, so that red spot will be covered. So how much we can do? There are limitations. Okay, and so or we have to do lot of mathematics. So that we'll cover that how we can solve this. Okay, so that we'll see in the concept of texture object and its attribute, and then texture unit and texture object. So that we'll see, and then how photographs are getting generated and how it is getting laid out.